All right, good evening. Welcome to Internal Logistics Weststock. For those who don't know me, my name is Ray Rutia, Group Leader. Safety commitment is I will ensure members always maintain safety first mindset while in process through process observation, standard work audits. So here, let me introduce you to the Weststock Blue Squad. We got our circle leader, Derek Sines. We got our circle members. We got Roger Romero. We have Michelle Escalera, Joseph Torres. Unfortunately, Tommy Brooks could not be here. Then next, we got Luis Gonzalez, and then we got Jesse Gonzalez as well. So now I turn it over for Derek to start the report out.
Hello, our theme is no good bookie calls from team members. Our team members have little knowledge of participating and completing participating and completing in QCC. So our basic goal was to teach the structure and the format to participate, as well as using graphs to represent data in the QCC. We developed an activity plan which gave roughly about a month for each of the 8 steps to complete. So our final completion should have been around October. Any countermeasure that we developed, we wanted to happen sometime between June and July for fabrication purposes during shutdown time. So for our theme selection, I allowed the team members to tell me what they believed was their top safety and productivity issues according to their voice. So each of these themes also ties into Hoshin's on Weststock. We had poke-yoke efficiency on routes, which ties into safety, productivity, and cost. We had parts delivery method improvements, which ties into safety and productivity. And we had parts overflow management, which ties into our productivity and cost. Poke-yoke efficiency scored the highest with a 26, so that's the route we took. Next, Michelle will continue.
Step 1. Clarifying the problem. The ultimate goal is to deliver the right amount of parts to the right time safely and efficiently. Our ideal situation, there should be no poke-yoke issues with dollies and trains and tuggers when the team members are in process. Our current situation is during February and March, there were 60 calls from team members to team leaders due to no good poke-yoke issues while in process. Relevance, stop and waits due to no good poke-yokes can lead to abnormal situations and possible part short downtime. We had a gap of 60 no good poke-yoke calls during this time. Now our poke-yoke system, as I can show you over here, when the team member hooks onto the train, it's at that time that we plug in to our poke-yoke system with the cord here. This cord runs throughout the train, where the cord attached to the limit switches and the gates. Now, we have a red light on the tugger showing whether we have a good condition or good condition. If we're in a good condition, as we take off, there is no red light flashing. Now, if we're in a no good condition, the red light flashes. That's when we stop, call, and wait. And most likely, it's going to be the cord, the limit switch, or the gates. That's a possible defect. And now I will turn it over to Roger.
Step 2, breaking down the problem. So as Michelle mentioned, we had 60 poke-yoke issues, a gap of 60 poke-yoke issues. From the data we collected, we identified 3 contributing factors, and they were torn wires, disconnected wires from the actual tugger, and broken limit switches. So in order to isolate the point of occurrence, we began documenting where most of these issues were coming from. We had 10 issues with the tugger themselves, 42 issues with the dolly train, and 10 with the connecting cables. Because of this, we decided to focus on the trains, obviously. So upon further investigation, we found that we had 18 occurrences with the engine SPS dolly, and of those 18, 10 of them came from Route 14. And of those 10 issues, 7 occurred on dolly number 2. And breaking down even further, of those 7 issues, 6 of those no good poke-yoke were due to broken limit switches. And this is what we identified as our prioritized problem. So the way our process works is it begins with us coming into the handover with an empty train. We hook up to a full train, check our poke yoke, check our sequences, make sure that we're in a good condition. We take off, we deliver. Simultaneously, the supplier takes the empty, they fill it, they bring it back, we return, drop off our empty and hook up, and it was at that time we were noticing we were getting our no good, we have to stop calling wait. And that's what we identified as our prioritized problem of occurrence in which team members had to call our team leaders. So our problem statement is team members are coming to a stop calling wait situation due to no good poke yokes when we're picking up the full trains from the handover. With that said, I'm going to pass it on to Joseph to cover step number 3.
All right, step number 3, set a target. Our target was to eliminate no good poke yoke calls that are stemming from issues with the limit switches on Route 14 trains Dolly 2 engine SPS dollies. This will reduce the overall gap 1%. Target date of completion 8 shows our no good poke yoke calls for Route 14 Dolly 2 was train 6. Our 100% elimination was our goal, 0. And then this was for the overall calls that we received. And I'll pass it to Derek for our next slide.
Okay, for root cause analysis, we broke down the problem further. Prioritized problem point of occurrence was limit switches on Route 14, Dolly 2, are being damaged. This is causing West Dock team members to call TLs for no good poke yoke situation when they pick up their full routes in handover zone. We broke it down using the 4 M's, man, method, machine, and material. Through our data that we gathered, man and machine did not have a direct impact to the root cause. So with method, we have the limit switches on Dolly 2 are being damaged. Why? Because the limit switches are coming into contact with objects, pillars, guardrails, or other routes. Why? The supplier must swerve around stationary routes that are completing their processes at the time. And why? Because the suppliers are following their standardized work. We believe this is a contributing factor, but not the root cause. So materials, we broke it down into 2 sections, the drive aisles and the limit switches themselves. So for material, we have the limit switches on poke yokes on Dolly 2 are being damaged. Why? Because they're coming into contact with guardrails, stationary objects, etc. Why? Because the suppliers are following their given drive line down the pathways that they have. And why? Because the supplier is following their standardized work, but their pathways may not be to standard. We believe this is a root cause, but not contributing factor, but not the root cause. So we broke it down to the limit switches, which is the limit switches are being damaged on Route 2, Dolly 2. These are coming into contact with the guardrails, other routes, stationary objects. And why? And what we believe the root cause is that the limit switches are exposed and mounted outside the framework of the dolly itself. If they were inside the framework, they wouldn't have the ability to become damaged. So this is our root cause. Through Genshi Genbutsu, we went and took pictures of possible areas where damage could occur, and also different situations that suppliers may come into, which leads to possible damage just being too close to other routes. And I will pass it on to Louis.
Step 5, developing countermeasures. We used our countermeasure selection matrix to come up with 4 possible countermeasures. The first one was to change the supplier's standardized work or drive paths or their drive paths. Second, we could have redesigned our gate handles to allow a different placement of the limit switch. Third, we also could have just removed all poke yokes altogether. The fourth one that we went with, and that's the one we chose, was to create a guard or bumper and protect the existing limit switch. That one placed highest on our matrix. We felt that we could accomplish that goal in a timely manner and through in-house, either through TPM or through Kaizen support. So step 6, we're going to go to see our countermeasures through. We set up an action schedule, began in June and ended in August, centering around shutdown. First off, we brainstormed ideas. we selected a consensus plan design. We got a list of materials, costs, and time needed. We ordered our materials. We built a trial guard, and then we installed it on Route 14, Train 2, Dolly 2. So you can see currently, before condition, it was exposed. And this one's a better picture. You can look at the dolly over here, how it's secured the gate and the limit switch from being hit. So next, I'm going to hand it over to Jesse for step 7.
All right, so in step 7, we wanted to monitor the results. So train 2, dolly 2, engine SPS was our highest point of occurrence. So for our initial trial, we decided to create a guard for train 2, dolly 2. So from 722 to 802, our trial showed that 2 calls were for train 1, 0 calls were for train 2, and 1 call was for train 3. So with that, we had 0 calls, and we decided to put the other 2 guards on the other 2 trains. With Route 14, dolly 2 as a main issue, on 7 of the 60 calls, 6 calls were due to damaged limit switches, which was our prioritized problem. So we eliminated all calls, which led to a 10% overall reduction in no good calls. And Joseph will explain step 8.
All right, step 8, standardizing Yokotan, or successful processes. The guards were put on all remaining engine SPS dollies for Route 14 due to the success of the first that we implemented. We also Yokotaned it to Route 12, as Route 12 is the mirror route to Route 14. So they do exactly the same thing, just different times. And this churn helped to eliminate a total of 18 no-good Pokio calls. This brought the total calls down to 42 from 60, which is a 30% decrease in no-good Pokio calls. We updated pictures for standardized work for routes 12 and 14 process manuals and continue to monitor our countermeasures. We have also Yokotan a similar version of this countermeasure to our pipe tank route to protect the Pokio from being damaged when loading engine pipes at the offsite supplier by their forklifts, and that's here at the bottom left, or your bottom right. So we have our switches right here, and then they were getting damaged when we were getting put in, so we put our countermeasure right here to block and save and keep it safe so it doesn't have to be replaced. Our estimated cost and savings. Our first year, our estimated cost and savings is going to be $294, and per year it's $882 due to the price of the limit switches. All right, I'll pass it to Derek. Oh, to Michelle.
All right, review and future plans. Our team assessment level rose from 1.4 to 1.8. We gained better general knowledge of the quality circles, the steps to complete one, and how to work together. There are continued plans to work with suppliers to check standards and improve drive aisles. All drive aisles should be to the same standards throughout the plant. With this countermeasure, we are removing the need to stop calling weight due to damaged Pokios. Our future plans, we are looking into creating a standard of requiring all hardware gates, locks, limit switches, etc. to be placed inside the framework of the dollies for all internal logistic routes. And this concludes our QC circle for the Blue Squad. Thank you.
Thank you, team. Not always easy reporting out. Team members, appreciate your hard work, putting effort. Derek, thank you as a circle leader.